Hey guys, welcome to my new video for M.Sc Mathematics. So in this video I'll be going to give you some notes for topology, which are very much required to understand the topology in deeper. I mean to dig deeper, we should know all of these things because I'll be going to upload question answers for topology. So to understand those, you have to understand everything which I am giving you in this note, right? So let's start. Don't waste the time. What is interval? A period between two events or the space between two points, right? A period between two events or the space between two points is called an interval. So we can say like that A, B, then C, D, right? So this is an interval, this is an interval, this is an interval. Now what is open interval? An interval that does not include its end points and is denoted by the first brackets, open first brackets and close first brackets. Okay, so the open interval 0 to 1. Okay, so the open interval 0 to 1 is the set of all real numbers between 0 to 1 but does not include either 0 or 1. So in the set builder form we can write like x such that x greater than 0 but less than 1. So if what does that mean? If we say that x greater than 0 but less than 1, that means that 0 and 1 are not included in the open interval. Okay, so what is closed interval? An interval that includes its endpoints and it's denoted by square braces, open square braces and close square braces. Okay, so the closed interval 0 to 1 is the set of all real numbers from 0 to 1, right? From all real numbers from 0 to 1. That means it is including 0 and 1. So in the set builder form we can write that x such that x is greater than equal to 0 and less than equal to 1. So 0 and 1 are included in it, right? So 0 and 1 are included in it. So what is neighborhood? Let R be the set of real numbers and A be a point belongs to R. Okay, then any open interval containing the point A, is called a neighborhood of the given point A, right? So let us suppose we have A equal to 0 and it belongs to R, right? Where R is the set of real numbers. Then we can say that -1, 1, -2, 2 are the neighborhoods of 0, because if we see that 0 will lie between -1 and 1, right? 0 will lie between -2 and 2, even 0 will lie between -3 and 3 and -4 and 1 and so on, right? So you can say these are the neighborhood of A. Okay, if A equal to 0. Now what is deleted neighborhood? Any neighborhood of a point A from which the point A itself has been deleted. Any neighborhood of a point A from which the point A itself has been deleted is called a deleted neighborhood. So for an example, if we see that let A is equals to 0 belongs to R, then if we make a difference of the open interval -1, 1 and 0, okay, the resultant will be the deleted neighborhood. Okay. Now what is interior point? Okay, what is interior point and exterior point? A point alpha of a set S is called an interior point if there exists at least, this means there exists, okay, if there exists at least one neighborhood of alpha which is contained in S, okay, which is contained in S. So if alpha belongs to S, okay, is an interior point of S. So if alpha belongs to S is an interior point of S, then there exists a point A greater than 0. Okay, then there exists a point A greater than 0, okay, such that alpha minus a close open interval alpha minus a alpha plus a will be the subset of S. Okay, will be the subset of S. So complement of interior point is called exterior point. What are the exterior point? The complement. Okay, what is complement? If you don't understand, go to my set theory. There you can understand that what is complement. So complement of interior is called exterior point. Okay. Now what is derived set? The set of all limits points of A, say of a set A. The set of all limits points of a set A is called derived set and is denoted by A dash, like this, A to the power dash. So for open interval 0 to 1, okay, what will be the derived set? Derived set will be the closed interval because it is including the limit points 0 and 1, right? It has no limit point. But if you want to find out the derived set of open interval of 0, 1, 1, we will get closed interval of 0, 1, 1. Okay, because it contains all the limit points, right? All the limits, right? It contains all the limit points, right? That is why the closed interval. So if we have two real numbers like a and b, or two natural numbers like a and b, then what will be the derived set? The closed interval of a and b will be the derived set. Okay, now what is the closure of a set? The union of set a and its derived set a is called the closure of a set, right? And it denoted by a bar. It is denoted by a bar. So a union the derived set of A will be the closure of the set. So A union derived set of A will be the closure of this set, right? And so if we have A equal to 0, 1, then what we have for the, you can say, derived set. For the derived set, we will have the closed interval of 0, 1, right? The closed interval, if we have a set which is like open interval 0 to 1, then the derived set will be the closed interval 0, 1, because it contains all the limits points of it, right? And then what will be the A union the derived set? A union derived set will be the closed interval of 0 and 1. Okay, then 0, 1 will be the closure of this set. Then 0, 1 will be the closure of the set, right? 0, 1 will be the closure of the set A. Now what is isolated point, right? What is isolated point? The points of a set which are not limit points are called isolated points, right? So every point of a finite set is a isolated point. So every point of a finite set is a isolated point. For an example, we take set of vowels A, E, I, O, U. So each of these will be the isolated points. Okay, each of these will be the isolated points, right? Because none of these are limit point. of this set. So what is a disjoint set? Two sets are said to be disjoint if they have no common elements. Okay. Okay. Now what is disconnected set? A subset S of real number is said to be disconnected if there exist two disjoint open set. What is disjoint set? I explained in the last page. Two disjoint open sets A and B such that S equal to A union B. And derived, what does that mean? What is this? What are these? Right? What are these? These are the what are these? I have already given you. What are these? Closure of the set. What are these? Closure of the set. So, and how we get closure of the set? To know, you need to know what are the derived sets. So what we are seeing here? A subset of S of real numbers is said to be disconnected if there exists two disjoint open set A and B such that S equal to A union B and the derived set of A intersection the derived set of B not equal to 5. Okay, the derived set or the closure of the set, right? What is the derived set and what is the closure of the set, right? So the derived set is not an the closure of the sets are not equals to 5. So to find out the closure of the set, we have to know the derived set, right? So derived sets are this, closure of the sets are this. So what is the definition? A subset S of real numbers is said to be disconnected if there exist two disjoint open sets A and B such that if we union this disjoint to two disjoint sets, we will get S, right? But if we do the intersection, of the closure of these two sets, now what is the closure of two sets? That is the set A and that is the union of the set A and the derived set. Union of the set A and the derived set. Union of the set A, B, union of the set B and derived set. So this is union of the set A and union of this set A and its derived set. What is this? This is union of the set B and its derived set, right? So these are the closure of the sets, right? This if we do the intersection of the closure of the set, so we will get null set, empty set 5, where A not equals to 5 and B not equals to 5. So if we have a set S 0 1 union 2 3, right? 0 1 union 2 3, where A equal to 0 1 and B equal to 2 3, open interval A equal to open interval 0 1 and B equal to open interval 2 3, right? Then what will be the closure of the set? What will be the closure of the set for A? It will be 0 1. It will be 0 1. The closure of the set. If you want to clarify, you just go to this previous page. You know what is the closure of the set, right? You know what is the closure of the set. Go here and understand what is the closure of the set. Okay. So closure of the set will be 0 1. Why closure of the set will be 0 1? Because A union derived set of A will return 0 1, right? That is why 0 1 will be the closure of the set for A. And what will be the closure of the set of B? It will be 2 3, because B union the derived set of B will be the closure of the set that will return 2 and 3, close interval 2 and 3, right? But if we do the intersection among these sets, right, what we will get? We will get 5, right? We will get 5. Even if we do intersection of A and B, A and the closure of B, we will get 5. If we do intersection of closure of A and B, we will get 5, right? So this set S can be called as disconnected. So the set S can be called as disconnected set, right? Again, I am going through a subset S of real number is said to be disconnected if there exist two disjoint open sets A and B such that S equal to union B and the closure of set A intersection closure of set B equals to 5, where A and B are not equals to 5. And I have given you the example, so please go through it, concentrate it, you will understand, you will understand. Okay, no problem with that. This is very simple way I am making you understand all these things. If you go to your book and try to understand this, it will become a bit complex for you to understand. But I have written these things in such a way that if you go through once, you will understand everything. If you have any difficulty in understanding this, go to set theory. Okay, go to set theory and the previous videos of topology. Okay, that will make things easier for you to understand. Now, what is connected set? A set which is not disconnected is connected sets. Okay, So let us consider S01 intersection 1 2. 01 union 1 2, 01 union 1 2. Let us consider as S01 union 1 2. 01 is the open interval in open interval and 1 2 in the closed interval. Okay, where A equal to open interval 01 and B closed interval 1 2. So what will be the closure of the set A? It will be 01. Okay, it will be the 01 closed interval 01, and what will be the closure of the set B? It will be again 1 and 2. It will be again 1 and 2, right? The closure of the set of closed interval is always returns the same closed interval, so it will be 1 and 2, right? Now if we do an intersection, if you do an intersection of A and B, you can see that 01 and 1 2, right? So if you do intersection, at least one will be common, right? At least one will be common. So that is why it will be not returning a phi. So this is called, then we can say this set maybe we are considering the set as S, so S is a connected set, right? Now what is a dense set? If xt is a topological space, then a subset of X is said to be dense in X if the intersection of set X and the subset A always return A which is not equal to phi, for all A belongs to the topology. Okay, so A is dense in X if X is a subset of closure of set A. So we can say that A is dense in X if X is a subset of closure of the set A. Okay, and A is nowhere dense in X if interior point of the closure of the set A equals to phi. A is nowhere dense in X if interior point of closure of the set A equal to phi, right? So these are the basic definition. Let's give you a question answer which often come in university examinations. Okay, so what is the question? That prove that a subset of a topological space is open. Prove that a subset of a topological space is open if and only if it is a neighborhood of each of its points. Prove that a subset of a topological space is open if and only if it is a neighborhood of each of its points. Okay, this is the question. So answer, let xt be a topological space and let G be an open set and that belongs to X, right? Let G be an open set and that belongs to X, mean that is this subset of Y. Let G be a subset of Y. Let G be open. Okay, then for each X belongs to G, there exists an open set G such that X belongs to G is open set, is subset of G. Okay, again I am going through. Let xt be a topological space and let G is a subset of X and let G be open. Then for each X belongs to G, there exists an open set G such that X belongs to G is subset of G. Okay, this shows that G is a neighborhood of each of its points. Okay, this shows that G is a neighborhood of each of its points. Go to my previous video, you will understand everything. If you had not gone through my previous videos, you may not understand one line of the question answer. That is why in all of my previous videos I have told you that to understand the question answers you should know these things. If you don't know these things, you will not understand the question answers. Okay, because when I am going to give you the question answer, I cannot explain what is open set, right? What is neighborhood, right? That is why I have explained everything in my all of previous videos. Okay, Conversely, let G be a neighborhood of each of its points, right? Conversely, let G be a neighborhood of each of its points. If G not equals to phi, then for each x belongs to G, there exists an open set. There exists an open set G alpha, okay, such that x belongs to G and x belongs to G alpha, and what will be that? That will be a subset of G, right? That will be a subset of G. And if G equals to alpha, it is clearly open. If G belongs to alpha, G equals to alpha, it is G equals to phi, it is clearly open. If G equals to phi, it is clearly open. What again I am going through? If G not equals to phi, if G not equals to the null set, then for each x belongs to G, there exists an open set, right? G alpha, such that x belongs to G alpha is the subset of G. And if G is equals to phi, that means if G is equal to empty set, it is clearly open. It is clearly open, okay? Then it is clear that G equals to union of G alpha in the set builder from x belongs to G, right? G equals to union of G alpha where x belongs to G, okay? But each G alpha being open, but each G alpha being open set, and the arbitrary union of open sets being open, okay, it follows that G is open, right? It follows that G is open. So what was the question? Prove that a subset of a topological space is open if and only if it is neighborhood of each of its points, okay? So how do we prove that? We consider xt as a topological space, okay? Then we are considering G as a subset of x, okay? Now we are considering G is open, okay? Then what you know for that? That for each x belongs to G, there exists an open set G such that x belongs to G will be the subset of G, right? This shows that G is a neighborhood of each point, neighborhood of each of its points, right? Conversely, let G be a neighborhood. Conversely let G be a neighborhood of each of its points, right? If G not equals to the empty set, then for each x belongs to G, there exists an open set G alpha such that x belongs to G alpha will be the subset of G, right? And if G equals to phi, it is clearly open. It is clearly open. Then it is clear that G equal to union of in the set builder from G alpha x belongs to G, right? But each G alpha being open set and the arbitrary union of open sets being open, it follows that G is an open set, okay? So this is the question which often come in university examination. So you take a screenshot of this. Even I will suggest that whatever I am showing, take screenshot of this, then pin up. It will become a very good notes for you, okay? Pin up in sequence, it will become a very good note for you. Subscribe my channel to be notified for all of these kind of questions, because I have already started uploading question answers for topology and abstract algebra. So in future videos I'll be uploading much more questions. So if you want to go through these things, please subscribe my channel, please like my channel, and at least there is one thing in the world which never decreases when you distribute, that is knowledge. So please share this video also. Thank you for watching. Bye.